Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. My name is Associate Professor Dr. Ahmad Umizi bin Hilmi. In today's video, I'm going to talk about chapter 17 for flexible mechanical elements from the book Shigley Mechanical Engineering Design. Okay, this is for the subject EPT 315 machine component design. Okay. Okay, I try my best to show you this subject. I'm going to use three window frame, which is the PowerPoint, the the PDF, okay, about the textbook, okay, the Shigley Mechanical Engineering Design, and also from Google Images, so that I can type all the names of belt and chain drive so that you can understand. Okay, so to learn from this subject, you better download the textbook from Google Classroom here. Okay, I will uploaded the textbook in the Google Classroom. You can download it and you open the chapter 17 if you have the textbook. If you also, you can open chapter 17 for the title belting. Exactly, the title is exact title is chapter 17, flexible mechanical elements. Okay, this is the first slide for this is the first video on the belting. Okay, I'm going to do it section by section. There will be many videos talking about belting until the end of the chapter. Okay, so we start with belting. Okay, I will switch between PowerPoint, Microsoft PowerPoint, and the textbook, which is PDF, and also Google Images, so that you can understand. Okay, so let's go for the textbook, for the PowerPoint first. This is all the subject that we will cover, which is belting, 70.2 flat and round belt drive, and V belts, timing belts, roller chain, wire rope, and flexible shaft. Okay, this is all the subject that we will cover in the chapter 17. Okay, so characteristic of some common belts, they are flat belt, round belt, V belts, and timing belts. Okay, this is the figure. The flat belt is flat. Okay, the round belt is round, the V belt is like this shape, and the timing belt is like this. So to make you understand better, we look at Google Images. So what are the flat belts? What are the flat belts? Belt. Okay, flat belt drive. Okay, so this is the some of the pictures of the flat belts. You can see the belt are flat. The characteristic of belt is flat like this. Okay, you can see this is a flat belt, and this is the round belt. Okay, round belt pulley. Okay, you can see the belt itself is round. Okay, the belt itself is round, and then the V belt pulley. Okay, you can see it has a V shape like this. It has a V shape. Okay, it's like a V shape. You can put the pulley also have V shape, and the famous timing belt pulley. You have a car, you will know what is a timing belt. You have to do maintenance to change it after several kilometers, several thousand kilometers driving. You have to change the timing belt. Okay, this is all the basic type of belts. Okay, so the four principal belts are shown in table 70.1, which is this table. Okay, this is the table 17.1. Okay, this table, and the crown pulleys are used for flat belts, groove pulley or shift for round and V belt. Okay, what are crown pulleys? This is how you learn. When you read something that you don't understand, you just Google it. Okay, now it is easy because they have we have Google and everything. Okay, this is for the crown pulley. They have the straight face, combat face, crown face, straight taper and everything. This is the pictures of crown pulley. Basically I want you to have some idea how to use it, how to what is the pictures, what are the pictures of it. Okay, this is the crown pulley, and then what are the picture for used for flat belts, groove pulleys or shift. For groove pulleys, what are the groove pulleys? What are the groove pulleys? It has a groove like this. We have some groove. Okay, this is the type of groove. You can see here have groove. Okay, and then the shift. Okay, groove pulley of shift is also the same thing. Okay, ground pulley and shift is also the same thing. And for round and V belt, timing belt require 2/3 width or sprockets. Okay, I'm sure most of you have bicycle and motorcycle. You have the tooth wheel. Okay, I'm sure you most of you have motorcycle and bicycle, and also tiny car. You are familiar with this kind of gearing. Okay, you are familiar with kind of gearing. We have the tooth wheel, or you better known as sprocket. This is sprocket. I'm sure you are familiar with it. Okay, it is in your bicycle, in your motorcycle, and also at your car. Okay, so in all cases the pulley axis must be separated by certain minimum distance depending on belt type and size to operate properly. Okay, the other characteristics of belt are, okay, they may be used for long center distance. You see what are the meaning of long center distance. Flat belt drive. Okay, see this picture. Okay, you see this picture. This is the center drive. They have some distance to connect between two motor. Okay, they have a distance to connect between two motor. This is one motor, this is another motor, have a distance. Okay, this is what mean by long center distance. Okay, except for timing belt, there are some slip and creep, because so the angular velocity ratio between the driving and ribbon shaft is neither constant or exactly equal to the ratio of pulley diameter. Okay, so you see here timing belt, they have slip and creep. What are the meaning of slip and creep? Okay, you see the timing belt. Okay, because timing belt, okay, you see this timing belt, if we go down, if we go up, if we go down, if we go up, if we have some slip, if we have some creep. Okay, that is why this is what the meaning by this sentence, except for timing belt. Okay, in some cases, idler or tension pulley can be used to avoid adjustment in center distance that are ordinarily necessitated by age or installation of new belts. What are the idler or tension pulley? Okay, this is the tension pulley, this is the idler pulley. Okay, this is the idler pulley, meaning that if you want to connect with two or three motors. Okay, they have this connection. Okay, they have this connection, the idler pulley and everything. Okay, this is how you learn. When you don't understand, just Google it. This is a modern time. Okay, you lot of information, lot of resources, you can just Google it. Okay. And figure 17.1 illustrates the geometry of open and closed belt drive for a flat belt with drive with belt tension is such that the sag on group is visible in figure 17.2a. Where is 17.2a? This is 17.1. This is 17.2. 2a. Okay. No reversing and reversing belt drive, no reversing open belt, reversing cross belt. Cross belt must be separated to prevent rubbing if high friction material is used. Okay, this is what we learn next lah. The driver and the driven, driver and the driven. This is driver, the motor that have the engine that drive the motor, and this is the driven. It will follow what is the okay. This is what we learn next. There are some formulas that are quite complicated, but not that complicated. You should we will practice after this. Okay. So for a flat belt drive with this drive rotation as a drag and group is visible in figure 17.2a, where the belt is running, although the top is preferred or for the loose side of belt. For other types belts, either top or bottom may be used because their installed tension is usually greater. Okay, you can see this. You can relate it with bicycle. I'm sure most of you have a bicycle at your home, and also motorcycle. You can see how the chain is connected. Okay, the chain is connected. Okay, the two type of reversing drive is shown in figure 17.2. Notice that both sides of belt contact the driving and reverse pulley in 17.2, and you can see 2B and 2C. So this drive cannot be used for big belt or tiny belts. Okay, so this is the drive range and everything. You can see something to note. Okay, 17.1. okay, joint, yes, side range is 7.25 to 5 millimeter. Okay, we use millimeter. This textbook is from USA textbook, so of course they will use inches. Okay, so in Malaysia we use the metric unit, so we are more familiar with millimeter, meter and everything. So this is the range. E equals to 0.75 to 5 millimeter, and center distance no upper limit, and this round D. Okay, you see what is D, where is D, location of D. This is the diameter of D. So 1.8 inches to 4 inches, no upper limit. Okay, and then V belt. Okay, this is the V, the distance between the upper to the lower distance. Okay, V is 8 to 90 millimeter. Okay, center distance is limited. And timing belt, also P is the gear. If you learn about, you remember the subject gear, I taught you about the distance. Okay, P goes to 2 millimeter up and down. Also have limited. What is the meaning of limited? What is the meaning of limited here? You can see the timing belt. Okay, you can see the timing belt. Okay, the connection between this and this is have a distance. This is delimited by the distance. This is the limited, but limitation of the distance from to machinery, to motors, to crankshaft. This is the meaning by limited, because you don't have longer distance. Okay, of the timing belt, they have some limitation because of the engine itself. Okay, for the engine itself. About flat drive, is it can be as long as possible? Maybe. You can see the pulley. You can see pulley. Okay, pulley here. It can be as long as possible. Okay, you can see gantry and everything. They have a pulley. The pulley can be long. Okay, the pulley gantry and everything, they can be as long as possible, as long as you desire. Has no limitation on the length. Okay, so I think that's all for the video. today for this video. Next video we go for this equation, everything. Okay, okay, the mathematics with everything. So that's all. Wish you good luck. Thank you very much.